For all of human history, the night sky has been a familiar and unchanging map. The stars, from our perspective, are fixed and eternal, forming the beautiful and recognizable patterns of the constellations. They are the ancient landmarks of our cosmic home, the backdrop against which the slow, predictable drama of the planets unfolds. But the universe is a place of endless motion and profound surprises, and in recent years, we have become aware that our quiet, celestial neighborhood is occasionally visited by travelers from far, far beyond the borders of our own solar system. They are silent wanderers, ghosts from other stars, following their own lonely paths through the great, dark ocean of the galaxy. In 2017, we met the first of these visitors, the strange, asteroidal object named Oumuamua. In 2019, the second arrived, the more familiar, comet-like 2I Borisov. And then, in the quiet winter of 2025, our sentinels on a high mountain in Chile detected a third. This one was different. It was faster, it was larger, and its path hinted at an origin so ancient it predates the very birth of our own sun. This is the story of that third visitor. It is the story of the comet designated 3I Atlas, and this journey tonight is an attempt to trace its extraordinary path. We will follow this interstellar messenger on its one and only passage through our solar system. It is a journey that will take us from its recent discovery as a faint smudge of light, back across billions of years and thousands of light years, to its birthplace in a star system that is now long gone. A star system that belonged to an older and more chaotic generation of our Milky Way. We will then travel forward with it as it falls towards our sun and explore the clues that its strange and beautiful chemistry can tell us about the dawn of a galactic era that we have until now only been able to guess at. This is a story of a message in a bottle, a physical artifact sent to us not from another civilization, but from deep time itself. It is a quiet, cosmic detective story, and we will follow the evidence, one gentle step at a time. Before we begin to trace this visitor's ancient and epic path, I would love to know from which part of our own quiet world you are joining this exploration tonight. Please write your city or your country in the comments below. It is a beautiful way to feel our shared sense of wonder as our planet receives this guest from another star. And if you enjoy these calm and deep journeys into the mysteries of the cosmos, please consider subscribing to the channel. Your support is the energy that allows us to continue these voyages, always calmly, always at the pace of the universe. The story we are about to explore is a story that is happening right now. As of tonight, September 10th, 2025, Comet 3I Atlas is right now hurtling through our solar system, its path being tracked by the most powerful telescopes humanity has ever built. What makes this visitor so profoundly important is not just that it comes from another star, but what kind of star it seems to have come from. Its incredible speed, a velocity so high it cannot be easily explained by an origin in our local stellar neighborhood, is consistent with a birthplace in what astronomers call the thick disk of our galaxy, a puffier, older, kinematically hot disk component populated by ancient stars more than 7 billion years old. This means that the comet itself is a relic, a primordial snowball that is billions of years older than our own Earth. Furthermore, the light from its glowing atmosphere, as seen by the James Webb Space Telescope, tells us a strange and compelling story. It is made of a different kind of ice than our own comets, a composition dominated by carbon dioxide, a chemical fingerprint of a different and more ancient way of building planets. And so, our journey tonight will be a forensic one. We will begin with the moment of its discovery and the global mobilization of science that confirmed its extraordinary nature. We will then trace its path backwards, using its speed and trajectory as our guide, to imagine the ancient and long-dead star system that gave it birth. And then we will travel forward with it on its current path through our own solar system, exploring what our telescopes are telling us about this astro-archaeological artifact, this physical piece of a galactic dawn. Let us now quiet our minds and begin our journey, starting with the very first faint photons of light from this interstellar traveler to ever grace our world. Our story begins not with a brilliant flash in the sky, but with a quiet and almost imperceptible whisper in a stream of digital data. It begins in one of the darkest and clearest places on the face of our planet, the high, dry Atacama Desert of Chile. Here, far from the light pollution of cities, under a sky of breathtaking clarity, sit the silent, white domes of our great observatories. They are our patient sentinels, our tireless eyes on the cosmos. One of these sentinels is a robotic telescope, a key component of the Atlas survey. It is not a romantic, human-operated instrument. It is a quiet, efficient, and relentlessly methodical machine. Its sole purpose to scan the same patches of the southern sky, night after night, week after week, searching for anything that has moved, anything that is new, anything that is different. On the night of July 1st, 2025, it found something. A process of discovery in modern astronomy is a silent and subtle one. The telescope, in its robotic dance, took a series of digital photographs of a patch of sky on the border between the constellations of Serpens and Sagittarius. These images were then fed into a powerful computer, where sophisticated software began its patient work. The software's first task is to perfectly align the images. Its second task is to digitally subtract all the fixed and familiar objects, the distant stars, the faint smudges of far-off galaxies. What is left after this subtraction are the wanderers, the movers, the objects that belong to our own solar system. And on this night, a single, faint, and previously unknown point of light remained. At this moment, it was just an anonymous dot, with a brightness designated as magnitude 18. Which means it was millions of times fainter than the faintest star that can be seen with the human eye. To the system, it was given the temporary and unpoetic name A11PL3Z. In a different era, this faint dot might have gone unnoticed for weeks or months. But in our connected modern world, a quiet and beautiful chain of events was set in motion. The Atlas system, noticing the object's unusual trajectory, automatically sent its coordinates to a central, global clearinghouse for astronomical discoveries, the Minor Planet Center, or MPC. Think of the MPC as the great, silent switchboard of the solar system. When an alert for a new and unconfirmed object is posted there, on what is called the Near-Earth Object Confirmation page, it is like a quiet digital bell being rung in observatories all across the globe. It is a gentle but urgent call to the worldwide community of astronomers, both professional and amateur, to turn their own eyes to this new patch of sky and to confirm what has been found. And the community responded with incredible speed. Within hours of the initial alert, a global mobilization was underway. In the darkness of the Arizona desert, the Great Lowell Discovery Telescope slewed its mirror towards the coordinates. On the high, sacred mountain of Mauna Kea in Hawaii, the powerful Canada-France-Hawaii telescope paused its own deep sky survey to take a look. A network of other telescopes, all part of a global, collaborative, and almost organic system of planetary defense and discovery, all turned their attention to this one faint and mysterious visitor. This is the quiet, beautiful reality of modern astronomy, a global, human team working together across borders and time zones, united by a shared sense of wonder and a common quest for knowledge. These follow-up observations, all happening within the first 24 hours, began to reveal the true and extraordinary nature of the visitor. The first clue was a subtle but crucial one. The point of light was not perfectly sharp and star-like as a distant asteroid would be. The images revealed a faint, fuzzy, and marginal coma, a ghostly halo of gas and dust surrounding the object. This was the first definitive sign that A11PL3Z was not a dead, inert rock. It was an active, icy body. It was a comet. The second and even more stunning clue came as these new observations were used to refine the comet's orbit. The more data that was added, the more extreme its trajectory became. The path it was following was not a closed elliptical loop, the familiar path of an object that is gravitationally bound to our sun. Its path was a deep and unmistakable hyperbola. It was moving far, far too fast to be a member of our solar system. It was, without a doubt, a visitor from interstellar space. On July 2nd, 2025, the Minor Planet Center made it official. The temporary name vanished, and the comet was given its two new and historic designations. It was now C2025N1 Atlas, and more importantly, 3I Atlas. That simple 3I was a quiet but momentous declaration. Humanity was officially hosting its third known visitor from another star. The faint dot of light was no longer an anonymous candidate. It was a messenger, and the real journey to understand its message had just begun. The confirmation that the faint visitor, now named 3I Atlas, was a true interstellar object was a moment of profound and quiet celebration in the astronomical community. The bell had been rung for the third time in human history, announcing the arrival of another guest from an unknown star. But this confirmation was just the beginning of the story. For scientists, the most immediate and most crucial goal after any new discovery is to refine the object's orbit, to trace its path through our solar system with the greatest possible precision. An orbit calculated from just a few nights of observation is a good first guess, but it contains uncertainties. To truly understand a visitor's past and to accurately predict its future, astronomers need a much longer observational arc. They need to have seen the object not just over a few days, but over many weeks or even months. And in the modern era of astronomy, this is where the detective work truly begins. This is the art of the pre-discovery. A pre-discovery is a form of cosmic archaeology. It is the process of looking not forward into the sky, but backwards, into the vast, silent, and ever-growing digital archives of our great sky surveys. In the past, an astronomical discovery was a fleeting, momentary thing, a single observation that was recorded in a logbook. But today, telescopes like the Atlas Survey and the Zwicky Transient Facility, or ZTF, at the Palomar Observatory, are creating a digital history of the entire visible universe. Night after night, they patiently photograph the sky, storing petabytes of data, building a colossal, searchable library of what the cosmos looked like last night, last week, and last year. And so, the moment the first rough orbit of 3I Atlas was calculated, a new kind of hunt began. Astronomers now knew approximately where the comet should have been in the sky in the days and weeks before its official discovery on July 1st. The question was, had any of our robotic sentinels taken its picture without even knowing it? Computer algorithms were set to work, sifting through these immense archives, searching for a single, faint, and anonymous dot of light that matched the predicted path of the new comet. It is a search for a cosmic needle in a digital haystack of unimaginable size. And in the case of 3I ATLAS, this search was a spectacular success. Sifting through the data from the Zwicky Transient Facility, astronomers found the ghost of our visitor hiding in plain sight. They found images of the comet that went all the way back to June 14th, 2025. Further searches in the archives of the other Atlas telescopes in Hawaii and South Africa also revealed earlier unrecognized observations. This was the crucial breakthrough. The observational arc of the comet was, in an instant, extended from just a couple of days to several weeks. To understand the immense power of this, imagine you are trying to predict the full, graceful arc of a baseball that has been thrown. If you only see the first 2 feet of its journey as it leaves the pitcher's hand, your prediction of where it will land will have a very large margin of error. But if you are able to see the first 20 feet of its flight, your prediction becomes incredibly precise and confident. It is the same with a comet's orbit. By extending the arc of observation, astronomers were able to calculate the path of 3I Atlas with a new and breathtaking level of precision. And with this new precision, any last, lingering, and almost impossible shred of doubt about its origin was completely erased. The comet's path was so extreme, its speed so great, that it was now, with mathematical certainty, a true and bona fide traveler from the interstellar void. This rapid and successful process of discovery, confirmation, and prediscovery stands in beautiful and stark contrast to the story of our first interstellar visitor, Oumuamua, back in 2017. That strange and mysterious object was discovered late in its journey. It had already passed its closest approach to the sun and was already heading at high speed back out into the darkness by the time we first saw it. This created a frantic, reactive, and desperate scramble to observe it with every telescope we had, a race against the clock to gather as much data as possible before it faded from view forever. We only had a few precious weeks to study the Oumuamua, and many of its greatest mysteries, its true, bizarre shape, the strange reason for its gentle acceleration, remain unsolved to this day, precisely because we found it too late. The story of 3I Atlas demonstrates just how far we have come in only a few short years. We have now moved from an age of serendipity to an age of systematic preparedness. We have, in essence, built a beautiful, invisible, and globe-spanning welcome net for these visitors. Our all-sky surveys, our rapid alert systems, and our deep digital archives all work together now as a coordinated, proactive system designed to catch these messengers as they arrive, and to give us the one thing we need most to read their stories: time. The patient, meticulous, and collaborative work of hundreds of scientists around the world has now given us a great and precious gift. We have months to watch our visitor. We have the time to witness its story unfold as it makes its long and graceful journey towards its rendezvous with our sun. We have now told the story of the discovery of our interstellar visitor. We have seen how a single, faint point of light, captured by a robotic eye in a remote desert, can trigger a global cascade of scientific cooperation, transforming an anonymous object into a confirmed messenger from another star. The patient work of tracking its position and sifting through the great digital libraries of our past observations has given us the precious gift of time and a precise and detailed map of the comet's path. And it is in the elegant and beautiful geometry of this path, in the specific numbers that describe its trajectory, that we find the first and most irrefutable proof of its extraordinary origin. An object's orbit is its unimpeachable testimony, a story written in the language of gravity that reveals where it has come from and where it is going. And the testimony of 3I Atlas is a story unlike any we have ever read before. To understand this story, we must first understand the concept of orbital eccentricity. It is a single, simple number, represented by the letter E, that describes the shape of an object's orbit. An eccentricity of 0 describes a perfect circle, the most stable and simple of all orbits. As the number increases from 0 towards 1, The orbit becomes more and more stretched out, forming an ellipse. All the planets, asteroids, and most of the comets in our own solar system travel on these stable elliptical paths. They are like loyal members of a family, forever bound by the sun's gravity, destined to repeat their journeys in a great, predictable, and cosmic rhythm. An orbit with an eccentricity of exactly 1 is called a parabola. This is the precise shape of an escape trajectory. It is the path of an object that has just enough energy to escape the sun's gravity, but it will only just barely make it, its speed slowing to almost zero as it reaches an infinite distance. But the orbit of 3I Atlas is not a circle, it is not an ellipse, and it is not a parabola. Its path is a deep and profound hyperbola. A hyperbolic path has an eccentricity that is greater than 1. It is the signature of an object that is moving so fast that it is not and has never been gravitationally bound to our sun. It is the path of an intruder, a visitor who is simply passing through, following a trajectory that is almost a straight line through our solar system. The eccentricity of our first interstellar visitor, Oumuamua, was about 1.2. For our second, 2I Borisov, it was a much more extreme 3.4. The eccentricity calculated for 3I Atlas is a truly astonishing 6.1. Its path is so open, so unbound, that it is barely being deflected by the immense gravity of our own sun. This extreme path is the result of the comet's almost unbelievable speed. This brings us to the second key parameter of its orbit, a value known as its hyperbolic excess velocity. This is a measure of the comet's true cruising speed through the vast empty ocean of interstellar space. Its speed before it ever felt the accelerating pull of our sun's gravity. For 3I Atlas, this speed is approximately 58 kilometers per second. That is more than 130,000 miles per hour. To put that number in perspective, the fastest object ever built by human hands, the Voyager 1 spacecraft, is currently traveling out into interstellar space at a speed of about 17 kilometers per second. Our fastest messenger is barely a crawl compared to the effortless, immense velocity of this ancient traveler. This incredible speed is the second and perhaps most powerful piece of evidence that this object is not one of our own. No known process within our solar system, no gravitational slingshot from a giant planet like Jupiter, can explain how a comet from our own Oort cloud could have been accelerated to such a speed. It is a speed that could only have been inherited from its parent star, a star that was itself moving very, very fast relative to our own sun. The final piece of the orbital puzzle is its inclination. Imagine that our solar system is a flat disk, like a vinyl record, with the sun at the center and all the planets orbiting in the grooves. This flat disk is called the ecliptic plane. The orbit of 3I Atlas is inclined by about 175 degrees to this plane. This means it is on a retrograde orbit, moving in the opposite direction to the general flow of the planets. But interestingly, while it is moving backwards, its path is almost perfectly aligned with that flat disk, tilted by only about 5 degrees relative to it. It is like a car driving at an immense speed in the wrong direction, but perfectly within its own lane on the great highway of our solar system. These orbital parameters, then, are more than just a set of dry, descriptive numbers. They are the first crucial clues in our great detective story. They are the evidence that not only proves our visitor is from another star, but, as we shall soon see, they point us towards a very specific, a very ancient, and a very different part of our own Milky Way galaxy as its likely place of birth. The path of our interstellar visitor, 3I Atlas, has now been meticulously mapped. Its extreme and beautiful hyperbolic orbit is a bold and undeniable signature, a declaration written in the language of gravity that it is not, and has never been, a member of our own solar system. But the story written in its trajectory is far more specific and far more profound than that. The most telling clue, the single number that elevates this comet from a mere curiosity to an object of historic and scientific importance, is its incredible speed. That immense velocity of approximately 58 kilometers per second is an anomaly. It is a cosmic riddle. It is far too fast to be easily explained by the standard ways a comet might be ejected from a nearby star system. And in solving the riddle of this great speed, we are led to a breathtaking conclusion about the true origin of our messenger. It is not just a visitor from another star. It is a traveler from another, much more ancient age of our galaxy. To understand this, we must first create a simple mental map of our own cosmic home, the Milky Way galaxy. Let us imagine our galaxy is a vast and sprawling city of light. The place where we live, where our sun and all its closest stellar neighbors reside, is a region known as the thin disk. This is like the modern, bustling, and relatively flat suburbs of the city. Here, the stars, including our own, are relatively young and are all moving in the same general direction, orbiting the galactic center in calm, orderly, and nearly circular paths. They are all following the same gentle flow of cosmic traffic. The previous interstellar visitors, Oumuamua and 2I Borisov, were moving at speeds that were consistent with them having been ejected from one of these nearby, neighboring star systems in our own familiar thin disk. But surrounding this flat, orderly region of the city is a much older, more diffuse, and more chaotic neighborhood. This is the thick disk. This is the ancient historical part of our galactic city. It is a puffier, more spread out halo of stars that are billions of years older than our sun. These stars were formed in a much earlier, more turbulent, and more violent era of the galaxy's history. And because of their great age and their chaotic past, their orbits around the galactic center are very different. They are more eccentric, more tilted, and they have much higher random velocities. They do not follow the main, calm flow of traffic. They are the ancient wanderers, moving on their own, faster and more chaotic paths through the city. And here we find the beautiful and elegant solution to the riddle of our comet's speed. The 58 kilometers per second velocity of 3I Atlas is incredibly difficult to explain if we assume it was ejected from a normal star system in our own, calm, thin disk neighborhood. The gravitational kick required from a giant planet to fling a comet out at such a speed is almost impossibly energetic. The much simpler and far more likely explanation is that the comet was ejected at a perfectly normal, gentle speed from a parent star that was itself already moving at an incredibly high velocity relative to us. The comet, in a sense, inherited the great speed of its parent, and the stars that have these high, ancient, and chaotic velocities are the stars of the galactic thick disk. If this interpretation is right, the implication is staggering. The age of our visitor. The stars of the thick disk are on average billions of years older than our sun. If 3I Atlas was born in a planetary system around one of these ancient stars, then the comet itself must be incredibly old. Current estimates could place its age at more than 7 billion years. Let us take a quiet moment to contemplate that number. Our own sun, our Earth, and our entire solar system are only about 4.5 billion years old. This means that our interstellar messenger, this small and humble ball of ice and dust that is, at this very moment, passing through our home, is billions of years older than the Earth itself. It is a true pre-solar object in the grandest sense of the word. It was already a fully formed world, drifting in the darkness of its own home system, long before the cloud of gas and dust that would become our own sun had even begun to collapse. This transforms our understanding of what this comet truly is. It is no longer just a visitor. It is a relic. It is a pristine physical artifact from a bygone era of the galaxy's history. It is a time capsule, carrying within its frozen heart a direct and physical sample of the raw, planet-building materials that existed in our galaxy billions of years ago, a time when the chemical composition of the cosmos was different. This is the dawn of a new kind of science, a field that has been called astro-archaeology. For all of our history, we have studied the past by looking at the faint and ancient light from distant objects. But 3i Atlas has brought the past to us. It is the difference between reading a history book about an ancient lost civilization and having a perfectly preserved 7 billion-year-old tool from that civilization delivered directly into our hands. The path of our visitor has told us its story. It is not just a messenger from another star. It is a messenger from another and much more ancient time. The path of our interstellar messenger has now been traced back to its ancient and extraordinary origin. The incredible speed of 3i Atlas is a smoking gun, a clear and unambiguous piece of evidence that points to a birthplace in the old and chaotic halo of stars known as the Galactic Thick Disk. We have come to understand that this visitor is not just a piece of another star system, but a relic from another, much more ancient age of our galaxy. And now, having established its origin, we must turn our attention to the journey itself. A journey of more than 7 billion years, a voyage of almost unimaginable length and loneliness, through the vast, dark, and silent ocean of interstellar space. To truly appreciate our visitor, we must first try to comprehend the epic pilgrimage it undertook to reach us. Let us imagine the moment of its birth as a traveler, billions of years ago, in a planetary system orbiting a long-dead star. Our comet was just one of countless icy bodies quietly circling its sun in a distant, frozen orbit. But the gravitational dynamics of a young solar system are often a violent and chaotic dance, and in some long-forgotten gravitational interaction, a close pass with a giant planet, perhaps, or a disturbance from a sibling star, our comet was given a powerful gravitational slingshot. It was accelerated beyond its star's escape velocity and flung out into the great empty darkness. This was not a violent explosion, but a quiet and final act of severance. As it traveled outwards, its parent star would have grown smaller and fainter, eventually shrinking until it was just one of the countless, anonymous points of light in the sky, before finally becoming lost altogether in the dense, starry river of the Milky Way. The umbilical cord was cut. A great lonely voyage had begun. The environment of interstellar space, the great void between the stars, is the closest thing in our universe to a perfect and absolute nothing. The silence is total, a quiet so profound that it is not just the absence of sound, but the absence of a medium in which sound could travel. The darkness is near perfect, broken only by the faint, ancient, and impossibly distant light of other stars. And the cold is almost absolute. Just a few degrees above the theoretical limit of absolute zero, the temperature at which all atomic motion ceases. In this state of perfect cryogenic preservation, our comet drifted. For billions of years, it was completely inert, a silent, sleeping ghost, its precious, primordial ices locked in a deep and unchanging freeze. As it traveled, the eons passed with an almost unimaginable slowness. The universe around it was changing. On a distant, unremarkable arm of the galaxy, the great cloud of gas and dust that would become our own solar system was only just beginning to stir, to collapse under its own gravity. Our sun had not yet been born. Our Earth did not yet exist. As our comet continued its patient, silent journey, our own solar system ignited into life. The Earth was formed, a hot and molten world. Its great collision occurred, giving birth to our own moon. And still, our traveler journeyed through the dark. On our own world, the first, simple, single-celled life began to stir in the primordial oceans. And still, our traveler journeyed. The great, slow dance of continental drift began to shape our planet. The atmosphere filled with oxygen. And still, our traveler journeyed, a silent, unknowing witness to 1 billion years of our own planetary history, as seen from an impossible distance. The interstellar medium is not a perfect vacuum. Over the course of its journey, our comet would have passed through vast, diffuse clouds of interstellar gas, mostly hydrogen and helium, with a fine mist of microscopic dust particles. But these clouds are so incredibly tenuous, with only a few atoms per cubic centimeter, that the passage through them would have been almost imperceptible. It would be like a great ship passing through a light and scattered fog. For 7 billion years, this was the comet's existence, a slow, silent, and almost completely solitary drift through the near-perfect emptiness, its internal clock frozen, its substance perfectly preserved. It was a message in a bottle, cast out from an ancient shore, waiting for a destination it did not know it had. And then, after a journey that is longer than the entire existence of our own planet, by a remarkable and beautiful accident of cosmic chance, its lonely path finally brought it into the gravitational territory of a new and unfamiliar star, our Sun. At first, the Sun's gravity would have been an impossibly faint whisper, a tiny, almost unnoticeable pull in the darkness. But as the comet drew closer, over the course of the next 1,000,000 years, that whisper would have grown into a steady and insistent call, gently but inexorably bending the comet's path, guiding it inwards, towards the warmth and the light. The great, lonely, and silent part of its journey was over. The second act of its story, the brief, brilliant, and spectacular part, was at last about to begin. After a silent and solitary journey that has lasted for more than 7 billion years, a journey that is longer than the entire existence of our own planet, our interstellar messenger has finally arrived. The faint, almost imperceptible gravitational whisper of our Sun has grown into a steady and insistent call, a siren song of warmth and light that has drawn the ancient traveler out of the deep, interstellar darkness. The first, lonely, and almost eternal act of its story is over. And now, as it prepares to cross the threshold into our home, the second and final act, the brief, brilliant, and spectacular part of its existence is about to begin. Let us travel alongside it now, as it makes its grand entrance and awakens from its long cosmic slumber. The first frontier of our solar system is not a hard and definite line, but a vast, ghostly, and almost unimaginably large sphere of influence known as the Oort cloud. This is our own great celestial attic, a spherical halo of trillions of our own native comets held in a state of deep cryogenic sleep by the Sun's faint and distant gravity. Our visitor, Free Eye Atlas, now passes through this realm. It is an outsider, a stranger, moving through a silent, sweeping forest of its distant cousins. But its journey is profoundly different. The comets of our Oort cloud occupy extremely elongated, weakly bound orbits, closer to parabolic than circular, and they slumber far from the Sun until a distant perturbation stirs them. Our visitor, by contrast, is a bullet, a traveler on a high-speed, one-way trajectory, passing through this silent crowd with a purpose and a momentum that is not of this place. It is a brief and silent encounter, and in a few thousand years of travel, it leaves our own cometary cloud behind it. The journey continues inward. The Sun is no longer just the brightest star in the sky. It has now grown into a small but intensely brilliant disk of light. our traveler now crosses the second great frontier of our solar system, the orbit of the planet Neptune, and enters the region of the Kuiper Belt. This is a flatter, more crowded, and more dynamic region than the Oort cloud. It is a great icy debris field, the home of dwarf planets like Pluto and a billion other smaller icy worlds. The temperature here is still incredibly cold, but it is by a few crucial degrees less cold than the absolute chill of the interstellar void. The faint warmth of the sun is beginning to be felt, a hint of the great fire that lies ahead. Onward it falls, its speed constantly increasing as the sun's gravity pulls it in. It crosses the orbit of the great blue planet Uranus, and then the majestic ringed world of Saturn. And now, as it journeys inward, our comet crosses the classic water snowline, located between Mars and Jupiter at roughly 2.7 astronomical units, where water ice begins to sublimate efficiently. This is the point in our solar system where the warmth from the sun is finally strong enough to stir the ancient, volatile ices that make up the heart of our traveler. For the first time in more than 7 billion years, the surface of the comet's nucleus feels a meaningful warmth, and in this faint warmth, the Great Awakening begins. The process is a quiet and gentle one. The ancient primordial ices buried deep beneath the comet's dark protective crust of dust begin to sublimate. In the perfect vacuum of space, they do not melt into liquid. Instead, they turn directly from a solid into a gas. Imagine this 7 billion-year-old ice, which has never known a temperature more than a few degrees above absolute zero, finally feeling this gentle heat. It begins to stir. Pockets of the most volatile, frozen gases, like carbon monoxide, begin to erupt from deep within the nucleus, bursting through fissures in the crust like miniature, silent geysers. This is the comet's first breath, an exhalation held for an almost eternal length of time. These powerful jets of gas do not come alone. They carry with them vast quantities of the fine, dark, primordial dust that has been locked away and preserved within the ice since the comet was first formed in a long-dead star system. This great expanding cloud of liberated gas and dust begins to form a vast but incredibly tenuous atmosphere around the comet's small, solid nucleus. This is the birth of the coma. This is the moment of transformation. For 7 billion years, our visitor has been a dark, inert, and almost completely invisible lump of rock and ice. But now, in the space of just a few months, as it crosses this magical frost line, it is transformed. It has put on its beautiful, ghostly robes for its one and only performance in our sky. The coma grows, expanding to a size that can be larger than a planet, and it begins to glow with the soft, reflected light of our sun. The sleeping ghost has awakened, and now that it is alive, and now that it is speaking in the language of light, we can, at last, begin to read the ancient message that it has carried for so long, and from so far away. Our ancient and silent traveler, 3I Atlas, has now fully awakened. After a journey of more than 7 billion years through the near-perfect cold of interstellar space, it has finally crossed the threshold into the warmth of our own solar system. Its long slumber is over. The faint heat from our sun has begun to stir the primordial ices within its heart, and it has begun to breathe, surrounding itself with a beautiful, glowing atmosphere of its own ancient air. This glowing coma has made it visible to us, a new and temporary star in our skies. But more than that, it has provided us with a precious and fleeting opportunity. It has given us a sample of its substance, a chemical message from another time and another place, that we can read from across a gulf of millions of miles. And to read this faint and distant message, humanity has deployed its most powerful and sensitive eye, a great golden honeycomb of a telescope, floating silently in the cold darkness, 1 million miles from Earth. This is the James Webb Space Telescope, To call the James Webb a telescope is an understatement. It is one of the most complex and ambitious scientific instruments ever created. It is our great eye on the infrared universe, a part of the light spectrum that is invisible to our own eyes, but which carries the secrets of the coldest, oldest, and most distant objects in the cosmos. To see this faint infrared light, the telescope itself must be incredibly cold, just a few tens of degrees above absolute zero. To achieve this, it hides behind a colossal 5-layered sun shield the size of a tennis court, a magnificent and delicate kite that blocks the light and the heat from our own sun, our Earth, and our moon. It is from this place of profound and silent cold that the telescope turns its gaze to our interstellar visitor. As we have learned, the telescope's primary tool for this investigation is spectroscopy. By collecting the comet's faint infrared glow and its reflected sunlight, the James Webb Space Telescope acts as a great cosmic prism. It gathers the faint, precious photons of light from the comet's coma, and it splits them apart, spreading them into a beautiful and incredibly detailed barcode of light. And it was in this barcode, in the data that was collected and sent back to Earth in the late summer of 2025, that the first and most profound part of the comet's message was revealed. The spectrum showed the presence of many of the things we would expect to see in a comet. There was the familiar signature of water ice and of other frozen gases like carbon monoxide. But one signal, one chemical fingerprint, was so strong, so overwhelmingly dominant, that it immediately set 3I Atlas apart from every other comet we have ever studied. The coma of our interstellar visitor was found to be overwhelmingly rich in carbon dioxide. This discovery is a quiet and subtle one, but its implications are immense. In the comets of our own solar system, the ones born from the same cloud of gas and dust as our own Earth, water ice is by far the most abundant and dominant frozen material. Carbon dioxide is present, yes, but only as a much smaller secondary ingredient. Our comets are fundamentally dirty snowballs made of water. 3I Atlas is a different kind of creature entirely. It is a carbon dioxide comet. Its fundamental recipe is a different one. This chemical anomaly is the explanation for one of the comet's other great mysteries: its unexpected brightness so far from the sun. Carbon dioxide ice is much more volatile than water ice. Because carbon dioxide is far more volatile than water ice, a carbon dioxide-rich comet becomes active much farther from the sun, producing a large coma well before water sublimation dominates. This means that a comet rich in carbon dioxide will become active and produce a large, bright coma much farther out in the solar system, long before the sun is warm enough to significantly sublimate its water ice. The strange behavior of our visitor was a direct clue to its strange alien chemistry. But the most profound message of this chemical fingerprint is what it tells us about the comet's home. The specific chemical makeup of a comet is a fossil. It is a direct and pristine record of the conditions in the great swirling disk of gas and dust, the protoplanetary disk in which it was born. In a young star system, there are invisible boundaries known as snow lines. There is a water snow line, the distance from the star beyond which it is cold enough for water to freeze. Farther out, there is a carbon dioxide snow line, where it is even colder. The dominant chemistry of 3I Atlas tells us that it was almost certainly formed in a region of its own, ancient protoplanetary disk that was very different from the region where our own comets were born. It may have formed around a star that was much cooler and dimmer than our own young sun, or in a disk that was, due to its ancient, thick disk origin, simply richer in carbon and oxygen than our own was. This is the great and beautiful power of astroarchaeology. The James Webb Space Telescope, by reading this faint chemical light, has allowed us to perform a chemical analysis of a 7 billion-year-old sample of another long-dead world. The message is clear. The way our solar system was built is not the only way. The recipe that created our home is not the universal recipe. The galaxy is, and has always been, a place of immense and beautiful chemical diversity. Our visitor is not just a different object. It is a representative of a different and more ancient way of cosmic creation. The James Webb Space Telescope, with its great golden infrared eye, has given us the first and most profound part of our messenger's story. It has acted as our cosmic chemist, reading the beautiful and complex barcode of light from the comet's coma and revealing its strange, ancient, and carbon dioxide-rich nature. It has told us what our visitor is made of. But to build a complete picture of this traveler, we need more than just a chemical analysis. We need a portrait. We need to see its shape, its form, and its activity. And for this task, humanity has another great eye on the heavens, a telescope that has become a beloved and iconic part of our culture for more than 3 decades. This is the Hubble Space Telescope. If the James Webb is the great chemist, then Hubble is the great artist, the portrait painter, giving us the sharpest, clearest, and most detailed visible light pictures of the cosmos that we have ever seen. In the late summer of 2025, after the initial revolutionary findings from Webb were revealed, the call went out to Hubble. It paused its own deep and patient observations of distant galaxies and turned its venerable gaze to our new and nearby visitor, 3I Atlas. Its mission was to solve one of the most difficult puzzles in cometary science, to try and see the unseeable. It was to try and catch a glimpse of the tiny, solid nucleus at the very heart of the comet. This is a task of immense difficulty. A comet's nucleus is a tiny, dark object, and it is shrouded in the brilliant, glowing fog of its own coma, an atmosphere that can be thousands of times larger than the nucleus itself. It is like trying to photograph a single, dark piece of coal hidden inside a colossal, brilliant, and glowing cloud. The images that Hubble sent back were a masterpiece of astronomical observation. They were so sharp, so clear, that they allowed astronomers to peer deep into the very heart of the glowing coma. While they could not see the solid nucleus directly, it was still too small and too overwhelmed by the light of the coma. They could do the next best thing. By measuring the precise brightness of the central point and modeling how the light from the coma was distributed, they were able to place a strict and definitive upper limit on the nucleus's size. The final result, announced in late July of 2025, was that the nucleus of 3I Atlas could be no larger than 5.6 kilometers, or about 3.5 miles, in diameter. It could, in fact, be much smaller, perhaps as small as a few hundred meters, but it could not be larger. Let us take a moment to imagine this. An object, perhaps the size of a single large mountain here on Earth, has traveled for more than 7 billion years through the vast, empty darkness between the stars to arrive in our home. Even at its maximum possible size, this makes 3I Atlas a larger object than our previous 2 interstellar visitors. It is a more substantial and more significant messenger. But Hubble's beautiful and detailed portrait revealed far more than just the comet's size. It gave us our first clear look at its physical activity, at the way this ancient and frozen world was responding to the warmth of our sun. The images showed that the coma was not a perfect and uniform sphere of light. It was a dynamic and structured atmosphere. From the side of the nucleus that was facing the sun, Hubble captured a beautiful and distinct plume of dust, a ghostly fan-shaped spray of material that was being ejected into space. This was the direct, visual evidence of the sublimation process. The geysers of ancient gas bursting from the surface and carrying with them the 7 billion-year-old dust that had been locked within the ice. The images also revealed that the overall shape of the coma was not spherical, but was being swept back into a gentle teardrop shape. This was the first hint of the comet's tail beginning to form. The gentle but relentless pressure of sunlight and the solar wind pushing the gas and dust away from the sun. By analyzing the colors of this dust, Hubble was able to confirm what ground-based observatories had already begun to suspect. The dust of this ancient visitor was distinctly reddish in color. This is not the color of simple gray rock. It is the signature color of complex, carbon-rich organic molecules that have been exposed to the harsh radiation of deep space for billions of years. It is another beautiful and independent piece of evidence that points to the comet's incredible and ancient age. And so, between these two great space telescopes, we now have a remarkably complete and vivid portrait of our visitor. The James Webb, the chemist, has told us that it is a carbon dioxide-rich world, a fossil from an ancient star system. And now Hubble, the artist, has shown us what it looks like. It is a dark, mountain-sized nucleus, wrapped in a vast, glowing, teardrop-shaped atmosphere, all the while unfurling a beautiful, ghostly, and reddish plume of 7 billion-year-old dust as it greets the light of our sun for the first and the only time. The great, golden eye of the James Webb Space Telescope has given us a glimpse into the chemical soul of our interstellar visitor. And the sharp, clear vision of the Hubble Space Telescope has painted us a beautiful and intimate portrait of its physical form. These two legendary instruments, floating silently in the cold darkness of space, have been our primary guides on this journey. But the story of 3i Atlas is not being written by them alone. As the Earth silently turns, a global and unbroken vigil is being kept by a network of powerful sentinels on the ground. They are the great terrestrial observatories, the quiet cathedrals of science, built on the highest and darkest mountaintops of our own world. While the space telescopes provide the breathtaking, high-fidelity solos, it is this global orchestra of ground-based observatories that provides the rich, continuous, and patient rhythm of our understanding. This global network is a beautiful and elegant solution to a simple, practical problem. Our planet rotates. For any single observatory, the comet is only visible for a few hours each night before the dawn washes it from the sky or the Earth's rotation carries it below the horizon. But by building a chain of these great eyes around the world, the observation can be passed, like a baton in a relay race, from one continent to the next. As the sun sets on the Atacama Desert in Chile, the darkness is just beginning to fall on the great volcanic peaks of Hawaii. And as the sun rises over the Pacific, the observatories in Australia and South Africa are opening their domes to the night. This allows for a near-continuous, 24-hour-a-day monitoring of our fleeting and precious visitor. Among the most powerful of these ground-based sentinels are the twin telescopes of the Gemini Observatory. One stands on the high sacred mountain of Mauna Kea in Hawaii, its brother on a remote peak in the Chilean Andes. These colossal 8-meter mirrors can gather immense amounts of faint light, allowing them to track the subtle day-to-day evolution of the comet. Their deep images have been crucial for watching the beautiful, teardrop-shaped coma grow and the first hints of the tail unfurl as the comet gets closer to the sun. They have also used their powerful spectrographs to measure the precise color of the comet's dust. By carefully measuring the amount of red light versus the amount of blue light that the dust reflects, a technique known as measuring color indices, they have helped to confirm that the dust is indeed a deep and distinct reddish color, the telltale signature of complex, carbon-rich organic molecules. This finding was first hinted at by one of the most historic and venerable of all our great telescopes, the 200-inch Hale telescope at the Palomar Observatory in California. In the first few days after the discovery, this legendary instrument provided some of the very first detailed characterization data, giving the world its first scientific confirmation that this visitor was not a simple gray, rocky body, but something far more ancient, organic, and interesting. And in a beautiful moment of cosmic serendipity, another great eye, one that is not even officially open for science yet, also played a crucial role. The Veracruz Rubin Observatory, also in Chile, is a revolutionary new kind of telescope, designed to photograph the entire visible sky every few nights with its colossal camera. In the late summer of 2025, while it was still in its engineering and commissioning phase, its powerful eye was already testing its systems. And by a stroke of good fortune, it captured a series of fortuitous, wide-field images of the region of the sky where 3I Atlas was passing. These early test images, while not their primary purpose, proved to be invaluable. They allowed astronomers to better model the faint outer reaches of the coma, which helped map the coma's extent and complemented the nucleus constraints set by Hubble. And this great professional effort has been supported by a beautiful global chorus of voices from the community of citizen scientists. Passionate amateur and pro-am astronomers from their backyard observatories or using networks of remote telescopes provided some of the very first confirmations of the comet's activity in the hours after its discovery. And they have continued to provide a constant stream of valuable data, patiently monitoring the comet's brightness and its changing appearance night after night. It is a beautiful testament to the power of a shared sense of wonder, a demonstration that the sky belongs to everyone, and that anyone with a passion for the cosmos can contribute to its story. The full, rich, and detailed story of 3I Atlas is therefore not being written by a single author, but by a global collaboration, a symphony of instruments and of human minds, all working together in a quiet and patient quest to understand the message of this beautiful and ancient visitor from another star. We have now assembled a remarkably detailed and intimate portrait of our interstellar visitor, 3I Atlas. Through the combined power of our great observatories in space and on the ground, we have learned about its ancient origins. We have mapped its extraordinary path. We have analyzed its chemical soul, and we have painted a picture of its physical form. But this comet is not just a solitary object to be studied in isolation. Its arrival is the third act in a grand and unfolding scientific drama. With its confirmation, humanity has now officially welcomed 3 known visitors from the interstellar void. And with these 3 precious data points, we can begin, for the very first time, to move from the study of a single strange anomaly to the study of a true galactic population. We can now place our messenger in context, comparing it to its predecessors, and in doing so, we can begin to read a much larger and more profound story. A story about the beautiful and surprising diversity of worlds in our Milky Way galaxy. Let us first, in our quiet journey, cast our minds back to the year 2017, to the arrival of our first confirmed interstellar visitor, 1I Oumuamua. It was a profound and baffling enigma from the very beginning. Unlike a traditional comet, it showed no visible signs of a glowing coma or a tail. It appeared to be an inert, asteroidal object, dark and reddish in color. Its most famous characteristic was its extreme, elongated shape, a conclusion that was inferred from the wild and dramatic swings in its brightness as it tumbled through space. It was a cosmic cigar, or perhaps a thin, flat shard, a shape unlike any known object in our own solar system. And to deepen the mystery, it exhibited a gentle but undeniable non-gravitational acceleration, a tiny push away from the sun that could not be explained by gravity alone. And yet, There were no visible jets of outgassing to account for it. Oumuamua was a profound and still unsolved puzzle. It was a messenger that arrived speaking a language we did not recognize. It was the great cosmic question mark. Then, just 2 years later, in 2019, our second visitor arrived, 2I Borisov. It was, in almost every way, the perfect and reassuring opposite of Oumuamua. From the moment it was discovered, Borisov looked and behaved almost exactly like a classic long-period comet from the most distant reaches of our own Oort cloud. It had a well-defined, glowing coma and a beautiful, long tail of dust. As our telescopes studied its chemical composition, they found that it was made of a familiar recipe of water ice and other molecules, in proportions that were remarkably similar to our own native comets. Borisov was a deep and profound comfort. Its message seemed to be that despite the vast distances, the fundamental building blocks of planetary systems, the dirty snowballs that form in the outer reaches of other star systems, might not be so different from our own. It was a familiar stranger, a welcome sign that the chemistry of our own home might be a common blueprint throughout our galactic neighborhood. It was the great cosmic reassurance. And now, into this small but already fascinating family arrives our third messenger, 3I Atlas, and it is, once again, completely and utterly different from the two that came before it. Like Borisov, it is clearly an active comet, with a glowing coma and the beginnings of a tail. But that is where the similarity ends. As we have learned, its chemical composition is deeply anomalous, a strange and exotic recipe that is dominated not by water, but by carbon dioxide. Setting it apart from Borisov and from all the comets of our own solar system, and its kinematics, its motion through the galaxy, are in a class of their own. Its incredible speed and its ancient origin from the galactic thick disk make it a fundamentally different kind of object from both Oumuamua and Borisov, whose gentler speeds are consistent with an origin from our own local thin disk of stars. So what is the great unifying message that these three messengers have delivered to us? The most profound and most important message of all is that there is no unifying message. The most significant finding is their incredible diversity. If our first visitor had been like Borisov, we might have concluded that all other solar systems are just like ours. If our second visitor had been like Oumuamua, we might have concluded that the galaxy is filled with strange and inexplicable objects. But to have three visitors, and for all three to be so profoundly different from one another, a strange, inert rock, a familiar water-rich comet, and an ancient carbon dioxide-rich comet, is the most exciting and most wonderful outcome of all. It is a powerful and direct piece of evidence that the process of building planets in our galaxy is not a uniform one. It suggests that the protoplanetary disks around other stars, with their unique chemistries, their unique temperatures, and their unique histories, are creating an immense and beautiful variety of building blocks. There is no such thing as a typical interstellar object. The galaxy is not a monoculture. It is a place of immense and wonderful variety, a great garden in which 1 billion different kinds of cosmic flowers are blooming. We have now assembled a beautiful and diverse family portrait of our first three interstellar messengers. We have met the great unsolved enigma Oumuamua. We have been comforted by the familiar friendly face of 2I Borisov, and we have been awed by the ancient and chemically strange nature of our current visitor, 3I Atlas. The most profound lesson from this small cosmic family is its incredible diversity, a lesson that the process of building worlds across our galaxy is a rich, varied, and complex one. But the story of our third visitor is not yet complete. The portrait we have painted is a magnificent one, but it is an initial sketch, not a finished masterpiece. For the story of 3I Atlas is a story that is still being written right now as we speak. As our visitor continues its journey towards our sun, our great observatories continue their patient vigil. And every new piece of data adds another subtle brushstroke to our understanding. And in these finer details, in the places where the data is still uncertain, we find the quiet, ongoing, and deeply human pulse of the scientific process itself. One of the first and most fundamental things that astronomers try to understand about any new world is its day. The length of a planet's or a comet's day, its rotational period, is a key piece of its identity. We measure this by watching the object's brightness over many hours and days. As the object tumbles through space, it will show us a slightly different face, and if it has an irregular shape or uneven surface features, its brightness will vary in a steady, periodic way. For a simple, inert asteroid, measuring this light curve is a relatively straightforward process. But for an active comet like 3I Atlas, it is a far more difficult and subtle art. The brilliant, glowing coma of gas and dust that surrounds the nucleus can often mask the faint, periodic signal of the solid body hidden within. And the nucleus itself is not a quiet object. It is a dynamic and active world with unpredictable jets of gas and dust that can erupt from its surface, causing its brightness to change in chaotic and non-periodic ways. And so we find ourselves with one of the first small and fascinating ongoing mysteries of 3I Atlas. We are not yet certain how fast it is spinning. One early study analyzing a specific set of data reported the clear detection of a rotational period of about 16 hours, a relatively slow and stately tumble for a body of its size. But another independent team of astronomers, analyzing a different set of observations taken at a different time, concluded that they could find no clear periodic signal at all. This is not a sign of failure or a contradiction. It is a beautiful and exciting glimpse into the scientific process at work. It tells us that our visitor is a complex and dynamic object. Its quiet, rotational whisper currently being drowned out by the louder, more chaotic song of its own awakening. To find the true answer, we will need more data, more patient observation, and a careful and subtle analysis to separate the signal from the noise. This is the nature of a living, breathing scientific investigation. It is not a straight line to a simple answer, but a slow and winding path, a conversation between different ideas and different interpretations of the data. And no scientific conversation is complete without its alternative viewpoints, the creative and critical voices that challenge the mainstream consensus and force us to think more deeply. The story of 3I Atlas, with its extraordinary speed and ancient origin, has a powerful and self-consistent explanation in the thick disk hypothesis. But other, more exotic possibilities have been proposed by creative thinkers like the astrophysicist Avi Loeb. He has suggested that the comet's incredible speed might be explained not by a gentle ejection from an ancient star, but by the far more violent and dramatic event of a planet being torn apart by the gravity of a dense star, like a white dwarf. These alternative ideas are a vital and healthy part of the scientific process. They force us to question our assumptions and to ensure that our preferred story is truly the best and most complete explanation for all the facts. And so the investigation continues. As we speak, in our quiet, shared moment of this journey, 3I Atlas is drawing ever closer to its perihelion, its closest approach to our sun at the end of October. This will be the moment of its greatest trial and of our greatest opportunity. As the heat from the sun becomes more and more intense, the comet's activity will increase dramatically. This peak activity may reveal new and deeper secrets, Will the increased stress cause the nucleus to begin to fragment, telling us more about its fragile internal structure? Will the more intense outgassing allow the James Webb Telescope to detect the faint, chemical fingerprints of new, rarer, and even more complex molecules that are currently hidden in its coma? Will we be able to measure the precise isotopic ratios of elements like carbon and nitrogen, a kind of cosmic DNA test that could definitively confirm its ancient and chemically different origin? These are the questions that we are on the cusp of answering. Our understanding of this messenger is not a finished story. It is a living sketch, and the most exciting and revelatory brushstrokes are still about to be painted. We have now reached a profound and beautiful summit in our long journey. We have followed the faint trail of clues left by our interstellar visitor, 3I Atlas, from its discovery as a faint smudge of light to the revelation of its ancient and exotic nature. We have compared it to its mysterious predecessors and found in their diversity a deep and wondrous lesson about the creative richness of our galaxy. We have patiently listened to the ongoing, quiet, and careful conversation of science as it seeks to understand this messenger. And now, as we begin our final, gentle descent, it is time to reflect on the ultimate meaning of this encounter. What does it truly mean for us? A species on a single, quiet world to receive a physical artifact from another star. The arrival of 3I Atlas is like finding a message in a bottle that has been drifting on the great cosmic ocean for more than 7 billion years. For all of our history, we have been island dwellers, looking out at that vast, dark ocean and wondering if any other islands, any other shores, even existed. The arrivals of Oumuamua and Borisov were the first pieces of driftwood, the first definitive proof that our island is not the only one. But 3I Atlas is something more. It is not just a piece of driftwood. It is a sealed vessel, a time capsule, carrying within it a pristine and readable message from a long-forgotten and faraway land. The bottle itself is the comet's nucleus, a dark and resilient vessel of ice and rock that has protected its precious contents from the harsh, empty radiation of interstellar space for a span of time that is older than our own sun. And the message inside is not written in a language of words or of symbols. It is written in the most universal and fundamental language of all, the language of chemistry and of physics. The ink of this message is written in the precise isotopic ratios of the elements within its coma. Isotopes, as we know, are different versions of the same element with slightly different weights. The specific ratio of, say, heavy nitrogen to light nitrogen or heavy carbon to light carbon is not the same everywhere in the galaxy, and it changes over cosmic time as generations of stars live and die. By using the James Webb Telescope to carefully measure these isotopic ratios in the gas of the comet's coma, we are, in a very real sense, reading a chemical timestamp. We are performing a kind of cosmic carbon dating that can confirm the comet's ancient, thick disk origin and tell us a story about the chemical state of the galaxy when it was born. The paper upon which this message is written is the rich and complex collection of organic molecules that are frozen within the comet's ice. These molecules, as we have learned, are the very building blocks of life as we know it. The specific mixture of these molecules, the precise recipe, tells us a story about the conditions in the long-dead protoplanetary disk where this comet was formed. It is a recipe for a world we will never see, a chemical ghost of a planetary system that was born, lived, and died long before our own Earth had even cooled from a molten ball. This is the true and profound meaning of the science of astro-archaeology. When archaeologists on Earth unearth an artifact from a long-lost civilization, a piece of pottery, or a simple tool, they can use it to reconstruct the story of a human past. The discovery of 3I Atlas is a moment of exactly the same kind, but on a scale that is almost too vast to comprehend. We have unearthed an artifact, not from a lost city, but from a lost star system. We have found a tool that allows us to reconstruct the story not of a human past, but of a galactic one. And the ultimate message that this ancient bottle carries is a simple and deeply hopeful one: connection. The very existence of 3I Atlas, its long and successful journey from its home to ours, is definitive proof that the star systems of our galaxy are not isolated islands. They are connected. The galaxy is a single, vast ecosystem that is constantly and patiently shuffling and sharing the materials for building planets. The journey of this one, small comet, proves that the building blocks of life, the water and the organic molecules, are not confined to their home systems. They are cast out upon the cosmic winds, and they travel, for eons, from one star to another. In this beautiful vision, the entire galaxy becomes a great and fertile garden, with the comets acting as the cosmic pollinators, carrying the potential for new life from one corner of the garden to another. The arrival of 3I Atlas is a quiet and profound family reunion. It is a physical reminder that we are not separate from the rest of the cosmos. We are a part of a great, interconnected, and ancient galactic heritage, and the atoms in our own bodies, forged in stars long ago, may have once been part of a similar silent traveler on a similar ancient journey. Our long and winding journey through the history, the science, and the very meaning of our interstellar visitor has now brought us back to the present moment. We have traveled across 7 billion years of its lonely, silent voyage, and we have explored the beautiful and complex message that is written in its ancient, icy heart. We have come to see it not just as a comet, but as a message in a bottle, a physical artifact from a long-dead star system that proves our galaxy is a vast, interconnected, and ancient place. And now, after all of this exploration of the past and the future, we must return our awareness to the here and now. For the story of 3I Atlas is not a historical one. It is a living, breathing story that is at this very moment unfolding in the sky above us. The great encounter is imminent. As we rest here, on this quiet night of September 10th, 2025, our messenger is no longer a faint and distant object on the outskirts of our solar system. It has completed the vast majority of its inward journey. It has crossed the great, cold expanse beyond Neptune. It has passed through the rocky territory of the main asteroid belt. And it is now deep within the inner sanctum of our solar system. Every single second, it draws closer to the sun, and its speed is increasing dramatically. It is now falling towards our star under the full and powerful influence of its gravity, accelerating to a speed that will soon reach its peak of more than 245,000 kilometers per hour. And with this increasing proximity to the sun comes an increase in its beautiful and revelatory activity. The quiet, gentle breathing that began as it crossed the frost line has now become a full and glorious song. The jets of carbon dioxide and other ancient gases are erupting from its nucleus with an ever-increasing ferocity, expanding its glowing coma to a colossal size and unfurling its two majestic tails behind it. Every single night, the global network of our ground-based sentinels and the great, silent eyes of our space telescopes are turning their gaze towards this single, magnificent object, capturing its every change, its every subtle transformation. The stream of data is constant, a river of new information that is allowing us to refine our understanding of this visitor in real time. We are living in the most exciting chapter of this story. The comet's path is now taking it towards its first close encounter with another world in our solar system. On October 3rd, 2025, just a few short weeks from now, 3I Atlas will pass within 18 million miles of the planet Mars. Our rovers and orbiters at the Red Planet will have a front row seat to this cosmic spectacle, and their observations will give us a unique and valuable perspective. But the main event, the moment towards which this entire 7 billion year journey has been leading, will occur at the end of that month. On October 29th, 2025, 3I Atlas will reach its perihelion. This is the point in its orbit where it is closest to our Sun. This will be the moment of the comet's greatest trial and its greatest glory. It will be bathed in the most intense heat and light it has ever experienced in its long existence. The sublimation of its ancient ices will be at its absolute peak, and the comet will be at its most brilliant and most scientifically revealing. Our telescopes will be watching, ready to read the deepest secrets from its heart as they are vaporized and released into the coma. But this will also be the moment of its greatest danger. The intense thermal and gravitational stresses of its close pass with our star will test the structural integrity of its ancient, fragile nucleus. Will it survive this fiery encounter? Or will it, like its distant local cousin, Comet C2019Y4 Atlas, succumb to the pressure and fragment into a ghostly chain of smaller pieces, its beautiful performance ending in a quiet act of self-destruction? We can only watch and wait. After it swings around the Sun, it will begin its long journey back out into the darkness. It will make its closest and completely safe approach to our own planet on December 19th, at a distance of about 1.8 astronomical units, roughly 167 million miles. And then it will have a final distant encounter with the great giant Jupiter in the spring of 2026. And then it will continue its journey, its speed slowly decreasing as it climbs back out of the Sun's gravity well, but always remaining fast enough to ensure its escape. This is our one and our only chance. This brief, fleeting passage is the only opportunity our species will ever have to study this messenger from a bygone galactic age. It will never return. We are the generation that has been chosen by the quiet, cosmic lottery to witness this beautiful and historic encounter. And so, for these next few months, a significant portion of our planet's scientific attention will be focused on this one beautiful and profoundly mysterious visitor as it completes its one magnificent performance in our sky. Our long and patient journey tracing the path of the interstellar visitor has now reached its quiet and final conclusion. We have followed the story of 3I Atlas from its initial discovery as a faint and distant smudge of light to the profound revelation of its ancient and exotic nature. We have traveled, in our minds, across a 7 billion year voyage through the lonely, silent darkness to witness this one brief and brilliant encounter in our own cosmic home. The message of this traveler is not written in words, but in the very substance of its being. It is a message of the galaxy's deep history, of its incredible chemical diversity, and of the beautiful, profound connection that all star systems and all times ultimately share. This ancient traveler's journey has been one of immense and quiet patience. And now, at the end of your own days long and often hurried journey, you are invited to find that same sense of cosmic patience within yourself. The story is told. The visitor, in our shared imagination, will now continue on its path, eventually leaving our solar system to travel onwards into the great, silent darkness from which it came. And you, in turn, can now continue on your own natural path. The gentle and restorative journey into the deep and healing quiet of the night. There are no more mysteries to solve, No more paths to trace. All that is left is this moment and the simple invitation to rest. Let go of the journey now. Let go of the story. Let go of the day, and allow yourself to drift, peacefully and effortlessly, into the quiet comfort of sleep. The journey continues, always calmly, always at the pace of the universe.